feasible. That means the energy involved at the initiation stage of the reaction must be enough feasible. That means the energy involved at the initiation stage of the reaction must be enough.
Good morning, students. I hope you're very much in the mood of learning today. My name is Unique Izuchukwu, your man DeGuru himself. Today we are continuing from where we stopped in our last discussion on organic chemistry. Precisely, we'll be looking at how we can classify organic compounds. Now, what we're doing today is very simple. Whatever I write or say and you're not very comfortable with it, feel free to ask your questions. Now, let's start this way. For you to classify, when you talk about classification, you are talking about grouping of certain objects according to certain things they share in common. Meaning that anytime you want to classify, there must be what we call a baseline for classification. There must be a criterion for classification. There must be a yardstick for classification. You don't just start classifying without choosing the basis for your classification. If, for instance, somebody says, go and classify SS3 students for me. I walk up to you as the guru himself and I say, student, come. Go and classify SS3 students for me. A good student will ask a question. The guru, did you say I should classify SS3 students for you? Yes. Okay. Sir, how do you want me to classify them? The reason is that a class of students can be classified based on their heights. In which case we'll have those that are tall and those that are dwarf. When I talk about dwarfs, I mean those of them that are very close to the floor. Most of those people you call short people. They are actually, you don't really call them dwarf. In fact, shortness is literary. Somebody you describe as a short man somewhere can go to another place and become a tall man. In fact, if you even say taller, a short man somewhere can become tallest in another environment. So you see that shortness is literary. But dwarfism is genotypic. The dwarfs are those of them that are very close to the floor. So if you are not tall, automatically you are a dwarf. So we can classify a class of students based on their heights. Okay, height becomes a criterion, the basis for your classification. You can classify based on complexion, based on color. You have the fair and you have the dark. What are you using to classify? Complexion, color. By the way, don't tell me you're chocolate. If you're not fair, automatically you're dark, because every trait is made up of two contrasting forms. We are coming to that in our biology. What's the news? Anytime you want to classify, there must be a criterion for classification. There must be a baseline for your classification. There must be a yardstick for your classification. Just like a class of students can be classified based on their intelligence, based on their mental potential, based on their faculty. You have the gurus and you have the mugus. You have the brilliant and you have the vegetables. What is the news? Anytime you want to classify class, there must be a yardstick for your classification. Now bring it back to chemistry and classification of organic compounds. When somebody says he wants to classify organic compounds class, there must be a criterion for classification. And what are those criteria we can use to classify organic compounds? Number one, we can classify organic compounds based on structure. Number two, we can classify organic compounds based on what we call functional group. Functional group. Organic compounds can be classified based on structure. Organic compounds can be classified based on functional group. So what are we going to be doing now? What do we mean by classifying organic compounds based on structure? And based on that yardstick, based on that criterion, what are the various classes of organic compounds we have? You know what? Once I write any organic compound after this lecture, you should be able to tell me the class it belongs in terms of structure and the class it belongs to in terms of functional group. That is what will say that you have become an authority in the classification of organic compounds. Class, follow me. Now, we are going straight away to what we call classification based on what somebody? Structure. When I talk about structural classification, I am talking about classifying organic compounds based on the carbon skeleton. Remember that we are talking about organic compound. I am not talking about organic element. I am not talking about organic atom. I am not talking about organic ion. All these things I'm mentioning are chemical species. Of course, you know that a compound differs from a molecule. If I write something like this, this is a molecule of nitrogen. A molecule of nitrogen. A molecule. Because you have two atoms of nitrogen that have come together to form this molecule. A molecule is that product formed when atoms of the same element are chemically combined. For you to form a molecule of nitrogen, one atom of nitrogen will combine with another atom of nitrogen to give you a molecule of nitrogen. So in a molecule of nitrogen, by molecule I'm looking at the coefficient. If there is no number that is following that element, it means that you have 1 mole of it. If you have more than one atom, it means that there will be a defined coefficient here. Assuming what I have is something like this. Look at this, class. The coefficient of nitrogen here is 2, which means we have 2 moles of nitrogen. Meaning that we have a total of 4 atoms of it. For you to get the number of atoms, you must multiply the coefficient by the subscript here. These 2 here tells us the number of atoms. These 2 here tells us the coefficient. So what I have represented here, when I write 2 N2, is only saying that we have 2 moles of nitrogen containing how many atoms of it? 4 atoms, because 2 times 2 here will give us 4 atoms of nitrogen in 2 molecules of it. But class, if I just write N2, you notice that the coefficient is 1. Mathematically, coefficient is the number that follows a variable. Variables are alphabets from A to Z. So when I write N2, I am talking about 1 mole, a molecule of nitrogen containing 2 atoms of it. So class, what is the news? This is a molecule. This is a molecule of nitrogen. Why did I call it molecule? Because you have atoms of the same element combining chemically. A molecule of nitrogen is formed by 2 atoms of nitrogen that have combined chemically. So a molecule is that product formed when atoms of the same element are chemically combined. But class, wait. Take a look at something like this. This is CO2, carbon 4 oxide. Am I going to call this a molecule or a compound? Class, you can see that I have atoms of different elements here. Carbon is an element. Oxygen is another element. So in this chemical species, we have atoms of different elements. 1 atom of carbon and the 2 atoms of oxygen that have been chemically combined. So what I have here is not a molecule, rather is a compound. So a compound is that product formed when atoms of different elements are chemically or somebody combined. So class, what is bringing me to the gist? Remember what we are discussing, structural classification. Classification based on structure. Follow me. Why am I discussing molecules? Why am I discussing compounds? Because we are talking about classification of organic compounds. So you must know what differentiates a molecule from a compound. A molecule, I said, is that product formed when atoms of the same element are chemically combined. But a compound is that product formed when atoms of different elements are chemically combined. Now, when I'm classifying an organic compounds based on structure, I am looking at the skeleton of the organic compound. I am looking at how the atoms that make up that compound are combined, how they are linked. Class, I am looking at whether the atoms that make up that compound are they linked together in an open chain, or are they linked together in a closed chain, closed chain. See what I mean by that? If I write something like this, carbon, another carbon, another carbon, this is carbon, carbon, carbon. This is a bond linking this carbon to another carbon. Okay? Now I have hydrogen here. I have hydrogen here. Hydrogen here. Hydrogen here. Hydrogen here. Hydrogen. 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 Remember that for any organic structure to be correct, each carbon atom must be surrounded by a total of 4 bonds. Once you represent an organic structure and you see a carbon atom there that is not surrounded by 4 bonds, it means that the structure you have represented is questionable. The reason is that carbon is tetravalent. Carbon exhibits valency of 4. So for any organic structure to be correct, each carbon atom there must be surrounded by a total of 4 bonds. That's why you have this. This is a bond. One bond, another bond. So you can see that there are 4 bonds surrounding each carbon atom you have in this structure. Ladies and gentlemen, how many carbon atoms do I have in this structure? How many carbon atoms do I have in this structure represented here? There are 3 of them. So this is the man I can refer to as prop. Prop. Whenever you have 3 atoms of carbon in an organic structure, the name starts with prop. We are coming to nomenclature. And because they are linked by single covalent bond, the name has to end with what? N, since it's a hydrocarbon containing carbon and hydrogen only. Now you notice that I am interested in how the atoms that make up this compound are linked together. They can either be linked in what we call open chain, as you can see here. The atoms that make up this compound are linked together in an open chain. The chain is open. They can also be linked together in a closed chain. Look at a case like this, class. If we represent something like this, please pay attention. Pay attention. This is like a triangle. We have a junction here. We have a junction here. We have a junction here. Now, because there are 3 junctions in this structure, it means that there are 3 carbon atoms. Anywhere you see a junction, it represents position of carbon. Now, remember that each carbon atom was surrounded by a total of 4 bonds. So you already have 1 bond, another bond, that's 2. So I have to bring in 2 atoms of hydrogen to complete the 4 bonds that must surround each carbon atom. Here, there is a junction. So this is a junction here. This is 1 bond, that's 2 bonds. Remaining 2 other bonds to complete the number of bonds that must surround each carbon atom in organic structure. So I make up using hydrogen atoms. Look at another junction here. This is a bond, that's 2 of them, remaining 2 to make it 4, because carbon is tetravalent, valency of 4. So in any organic structure, carbon must be surrounded by a total of how many bonds? 4 bonds. So that's what I have here. You can see that this is another organic structure. But the atoms that make up this structure are linked together in a closed chain. The chain is closed. Unlike here where the chain is open. So ladies and gentlemen, when the atoms that make up an organic structure are linked together in an open chain, it means that the organic compound or the organic structure belongs to a class of organic compounds we call acyclic compounds. Acyclic. Acyclic. Cyclic means closed. Acyclic means opposite of closed. That means open. It means that the organic structure has its atoms linked together in an open chain. That means that the propane I represented here is an acyclic compound because the atoms are linked together in an open chain. Class, this man here is also an organic structure. But I'm not going to place it in the class of open chain because the atoms are linked together in a closed chain. Remember, I still have 3 atoms of carbon in this structure. This structure before us still contains 3 atoms of carbon because there are 3 identifiable junctions. Remember, I told you that anywhere you see a junction, it represents position of carbon atom. So what does that mean? It means I can also start this name with what somebody prop because there are 3 atoms of carbon. I will also end the name with what? N because the atoms are linked together by single bonds and the structure is a hydrocarbon containing carbon and hydrogen only. Once you see a hydrocarbon, an organic compound that contains carbon and hydrogen only, and all the atoms that make up that structure are linked by single covalent bond, not double, not triple, the name must end with what somebody? N. It means it's a member of alkane. We are coming to that. The prop here means that there are 3 carbon atoms in the structure. Prop. If there are 2 of them, we say what? Eat. 1 of them we say meat. 4 of them we say but. We are coming to all this because very soon you will start singing with all this by the time we come to nomenclature. But ladies and gentlemen, we are discussing structural classification where we are looking at the carbon skeleton. So why did I say that this man is a closed chain compound? Because the atoms are linked together in a closed chain. Therefore, structurally, it belongs to a class of organic compounds called cyclic. Cyclic. That is to say that based on structure, an organic compound can be acyclic or what somebody? Cyclic. Now, in terms of nomenclature, what differentiates a cyclic compound from a cyclic one? Having written this propane you see here, I will come to this place and attach this prefix, cyclo, informing you that this is a cyclic compound. So the name of this closed chain compound will be what somebody? Cyclopropane. Prop because there are 3 carbon atoms. N because the atoms are linked together in single covalent bonds. Cyclo because they are linked together in a closed chain. Unlike here, where the atoms are linked together in an open chain. Remember I said N because I have a hydrocarbon whose atoms are linked together in an open chain. Prop because there are 3 carbon atoms. In fact, somebody can say normal propane. Normal was somebody? Propane, which is direct opposite of the cyclic one. Okay. Now, among the cyclic compounds, among the acyclic compounds as well, there are subclasses. Now, pay special attention because we are going to the technical aspect of the show. Class, follow me. Now, we are going to the subclasses. Acyclic represents a class of organic compounds whose atoms are linked together in an open chain. Among the acyclic compounds, we have a subclass we call aliphatic. Aliphatic. We have another subclass we call heterophatic. 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 We are going to take them step by step because there are so many technicalities, so many criteria, so many baselines we are going to use to differentiate them. Until I come your way, just stay tuned because we are going to a wonderful aspect of the show.